Today we will be making a simple adjustable timer circuit using basic components. Good day everyone and welcome to my channel. Let's quickly name the components. Starting from the left hand side, we have some copper cable that we will be using to do some bridging, some power cable, 300 ohm resistor, a MOSFET, any MOSFET will work, a relay, a little switch, a capacitor, 100 kilo ohm potentiometer, and an LED. That's all you need. Let's get started. For now we are just going to move a few components aside just to make life easier and just so there's nothing in the way. To start off with, we are actually just going to glue the relay to the table. Just off camera I'm grabbing some hot glue, just a small sliver of it. Here we go, just a tiny little piece of hot glue. I know it looks like a fingernail, but it's not. Just going to put it on the table. You're just going to use your soldering iron. Just give it a quick melt. Please remember to clean your soldering iron tip after this. Just like so. And we're just going to glue the relay straight onto the table. I know it looks like the relay is still loose, but that's actually the paper underneath the relay that I glued it to that's actually still moving. We're just going to go ahead and quickly pre-tin everything. Going to pre-tin one of the input coils of the relay and the drain of the MOSFET. Any MOSFET will do as long as it is a MOSFET, and N-channel MOSFET as well. Just going to quickly solder the two together. The input coils and the drain of the MOSFETs are going to get soldered together just like so. See how it just stays there now that the relay is glued to the table. Now you don't have to worry about things moving around and doing what it's not supposed to be doing. Just makes life a lot easier. Just going to quickly bend that MOSFET right up against the relay itself, just like that, nice and neat. And you can see the gate and the source of the MOSFET have been bent out. That will also make soldering easier and also keep things out of each other's way. Now let's quickly add the capacitor. We will add the positive of the capacitor to the gate of the MOSFET and the negative of the capacitor to the source of the MOSFET. Just like that. Let's quickly go ahead and solder that. Just going to pre-tin quickly. Pre-tinning always helps a little bit, just makes it easier. Then you don't have to try and add solder while you're trying to hold your component and your soldering iron. Just makes life easy, you know. Quickly pre-tin that capacitor, just like that. Now let's quickly put it onto the MOSFET itself. Remember, your positive of the capacitor goes to the gate of the MOSFET. I know what I'm doing here looks a bit sketchy, so don't burn yourself. It looks like I'm busy touching my own finger with the soldering iron, but believe me, I'm not. The soldering iron was still about 5 mils away from my finger, so don't worry about it. And also, I mean, burnt flesh doesn't smell that bad. I know from experience. There we go, just like that. Remember, positive of the capacitor goes to the gate of the MOSFET, and your negative of your capacitor goes to the source of the MOSFET. Please do not wire those incorrectly, as it will not work and it might go bang. Now let's quickly add the potentiometer. You can see this is a 100 kilo ohm potentiometer that we're just going to solder onto those little legs that were left over there, just like that. Quickly going to pre-tin all of that as well, just like so. I know my hands shake a lot, but it's winter currently where I live and it's cold, but that's okay, as long as I don't put solder everywhere else where it's not meant to be. Now that that's all pre-tinned, let's quickly add the potentiometer to the capacitor, gate, source and MOSFET area. Let's just quickly solder the other leg of the potentiometer to the source of the MOSFET. The source of your MOSFET and this side of the potentiometer will just go straight to negative on your power supply. And also, if you want to be fancy, you can add a switch between the gate and the source of the MOSFET, which would discharge the capacitor, which would switch off the relay, because there is no power that can flow through the MOSFET. But we're not going to do that in this video. Now we are just going to grab our switch. This is just a normally open switch, and we're going to take our positive wire, and we are just going to put one lead of the switch together with our positive wire. You can see there, one lead with a positive wire. Sorry, I'm accidentally doing that off camera, but I'll show you now. There we are. Just wrap it together just like that. And then, of course, we are just going to go ahead and pre-tin all of that again. Pre-tinning, like I said, makes it so much easier just to mount and solder everything together, because then you don't have to hold a piece of solder, your soldering iron, and try and balance a piece of wire or whatever else you're holding. Now what we're going to do, we're going to take that positive and the one side of the switch and solder that to the other side of the input coil of that relay. Just like that. There we go. And then we are going to take our 330 ohm resistor, and we are actually going to solder that onto the gate of the MOSFET. Just going to pre-tin quickly. You can see there I kind of soldered it in the middle of the leg of that resistor. It's because I don't need a very long resistor like that. I'll just cut off the excess. You can see that it's been soldered to the gate of the MOSFET. Quickly snip snip. There we go. Bend that nicely out the way so it's not touching anything else, like so. And then the other lead coming out of your switch you will solder onto the open pin of that resistor. Just wrapping it together to hold it all steady, and then we will quickly hit that with some solder. Just like so. There we are. Also snip snip again, don't need all that slack. The resistor is just there to make sure you don't send a very sudden rush of energy through your switch, because that might trip some sensitive power supplies, or yeah, it's just going to cause a whole bunch of trouble in the end. Believe me, I know, that's why I added there. Now we're going to take our negative wire and solder that onto the source of the MOSFET and the middle of the potentiometer. This will just be our common ground, negative, whatever you want to call it. Hit that with a soldering iron quickly. There we go. Later on in the video I'll take some time to explain how the circuit actually works. Now we are just going to take the LED and solder that onto the positive of the LED onto the normally open of this relay. Just going to quickly hit that with some solder again, pre-tin it. Solder the positive onto there, just like that. And then the negative wire is just going to go straight to the negative of, well, your negative of your circuit. Obviously you do not have to power LED with this. You can actually put 220 volts AC through there as well, but if you're doing so, please watch out and do not electrocute yourself, because it's not fun. There's some of that copper wire that I'm now using just to complete that bridge, that loop over there, to take positive to the common, and we are taking that positive straight from our positive of the end of the positive wire. Giving me a bit of trouble. It's a very funny angle, trying to stay out of the way of the camera and solder everything. There we are. Now let's quickly cut off that extra slack. I don't need that. I was going to cut it off, then I realized it's not actually soldered properly. It's difficult seeing if everything's soldered on properly when you're watching it through a camera screen. Alright, bring that out the way so we can quickly snip snip. Yeah, I probably should not have used the scissors for this, but it worked. Again, that thing just did not want to solder on, but now it is definitely guaranteed. Alright, we are almost ready to test. You can see there we've got the positive and negative cables, they're all stripped up. Now we're going to add the negative of the LED straight onto the negative of our input power supply, just like that. And yeah, now we are ready to test. I'll explain now how to tune the potentiometer, because if you have it too low it will not engage or trigger because of that little relay. As you can see, I'm going to press the button now and it's not going to trigger because the potentiometer is set too low. So all you do is hold the button down and slowly turn the potentiometer until the LED switches on. Then you know that is your minimum threshold or minimum time your timing circuit can do. And as you can see, press the switch and the LED stays on for a little bit. Tune it all the way down. I'm just going to show you this again. So you hold the button down and you slowly turn the potentiometer until the LED switches on, and that is your minimum time you can let the thing run for. There we go. I'm not going to tune this to the max because yeah, that is going to take absolute ages, but basically if you want this thing to run for a very long time or be active for a long time, just increase the microfarad of your capacitor. I'm using a 2200 microfarad capacitor, but you can use smaller or larger, depends on your preference. And like I said, I would explain how the circuit works. So basically a MOSFET gate needs voltage to be applied to it to switch on. So by you pressing the switch, you are charging up the capacitor, keeping voltage on the gate, which in turn switches on the MOSFET, allows power to flow through, switches on your relay. And the potentiometer just slowly discharges the capacitor to deplete the gate of any voltage, which would cause the relay to switch off. And that's very simple how the circuit works. Very simple, very easy to build, very easy to use. Hope you guys have enjoyed this video, and we will catch you in the next one. Cheers.